Okay, so welcome to question 3, 2017, paper 2. The Leaving Cert Ordinary Level Maths. And we're starting here with a coordinate geometry question. We have a rectangle labelled ABCD. We're given the points A, the points B, the points C, and the points D. And they make up the corners, the vertices of the rectangle. Part 1 that is shown is saying show that. Now these bars always mean the distance, the length of AD, so that's the length of this little bit here. Okay, and show that's equal to the square root of 5. So I suppose you could do it a few ways. Okay, you could use Pythagoras' theorem, make your triangle. Okay, and see this the square of the hypotenuse is your unknown. Does that equal the square of the other two sides? So square of what's that? 4? No, 2. 3 is the first one, so 2 units. It goes across by 1 unit. That's one way. Okay, you could use the distance formula. You are given the vertices, point A and point D, so you're focused on these ones here. Okay, that's probably the more standard way of doing it. That's how I did it here. So in the question, I've labelled the points. First X point, first Y point. Second X point, second Y point. Then written my formula out. Now the formula is given in the maths tables. Okay. And this formula is basically Pythagoras designed for coordinates. And I'm putting my x2 instead of, my 1 in instead of x2. My 2 in instead of x1. The 3 here instead of y2. And the 1 here instead of y1. If you have a negative number, I suggest putting in brackets. It'll make an extra step of simplification. But it'll mean you won't make an error. So if you're watching for minus times minus is a plus, in this particular question, if I can put that through the calculator if I want, or break it down and work it out, that should come out to be the square root of 5. So I've shown that the length of AD is equal to the square root of 5. Done it using Pythagoras or with the distance formula. That's part A. Now in part 2 it says find in square units. Okay, so the area of the rectangle ABCD. So area is length times breadth. So I have the breadth. I need to know the length. Okay. Now I find the length. I can find that by just calculating what DC is. I could do that using I could do Pythagoras as well, or getting the distance formula. I've used the distance formula here, same thing, except I just used the two different points. Put to the formula, I end up with square root of 20. Now, to my mind, that kind of stuff is bread and butter in past Leaving Cert. If not, it's worth going back and practicing. Okay, but like anything, and I suppose give yourself a break, in a sense, this is a formula. Okay, don't overthink it. Just know that where to find formula. Try find the one that suits best. Then input your numbers into the correct places. Okay, and then use the calculator to solve it out. So you can go straight from here to here. And always make sure you show this calculation. So if you do mess up somehow in getting to the answer, the sample calculation is there. And happy out. So in any formula, be it slope, midpoint, distance, modulus, any other number of formulae, area, surface area, volume. You just, once you have the formula, put the numbers you have in, or at least put some number that seems relevant in, to try and capture the low partial. Once I have my length of CD, so I now know that this is square root of 5, this is square root of 20, so multiply them together. We use the rule of powers here is to kind of show it. Okay, if you have two square roots multiplied together, you can write them under one umbrella, okay, under one continuous square root, and become square root of 5 times 10, which is 100. Now, if you know your square roots, you'd recognize that square root of 100 is 10. Now, or use the calculator. That's what it's for. Okay, so that's question 3, part 2, A, part 2. Now, into question B here. So that's the general equation for the equation of a line. Okay, and the Leaving Cert guys like it in that format. Personally, I prefer it in the format y equals mx plus c. It makes more sense to me. It's more descriptive, but I'm not setting the rules. So the question is find the equation of the line BC. So at least identifying what the coordinates B and C and writing them down will be a smart step. Okay, to find the equation of a line, if you know its slope and its y-intercept, then you can use them. But we don't in this case, and you're looking here at showing how using the equation of the line formula y minus y1 equals m times x minus x1. In that case, you need to know one point, B or C, and the slope between B and C. Okay, if you know those two things, you can calculate using the formula. So I've done here, I've found the slope. I've just screen printed in my 2 points. That's my, I'm going to find the slope here, so it's my first x, first y, second x, second y. So I put those things in, y2, so 5 take away 3 is the difference of the y's. 5 take away 6 is the difference of the x's. I end up then with the fraction 2 divided by -1, and that's the equivalent to -2. So if I use that, that's my slope. I have a point, I can pick either one. In this question I picked C, okay, no reason, just whatever. So I've replaced the y1 by 5 and the x1 by 5 and the slope by -2. Okay, that's done here. Then I'm going to remove the brackets. Okay, so simplify it as much as I can. And -2 times x is -2x. -2 times -5, minus by minus is plus, 2 5s is 10. So that's the simplification step done. And again, they want it in the form of a times x plus b times y plus c equals 0. Basically, that means they want everything on one side equals 0. So if I just move everything away to the same side, usually they want x being positive. Okay, so I'm going to say, well, the -2x, if I bring the -2x across here, the x will become positive. Bring the 10 across, I'll have everything on one side, and that should satisfy their requirement. When I do that, you end up with -2x is being added and subtracted to the right side, because the opposite to the left. Okay, then the 10 is being added on the right side, so your right side becomes subtracted on the left. Now, in the same step, I've done that calculation. -5 with the -10 gives you the -15 here. Now, that's everything on ax plus by plus c equals 0. So everything's on one side. That should be it. Now, part C here, okay, obviously give you a hint here saying use trigonometry to find the measure of the angle ABD. Okay, so let's try to find that first. It's the angle ABD. It's that angle there. Okay. And give your answer. Sorry, APD. You just get rid of that for a second. Here's a good example, which of course I was trying to get across, to read the question properly. Okay. Flaw of mine. Now, it's ABD. I could have very easily, if I was in a hurry or whatever, have misread that. And it would have probably given me problems, because finding ABD would be maybe a little more awkward. So ABC would be a little more awkward, which is why I would have read it being. So that's this line across here. That's the angle ABD down there. Apologies for the confusion. Now that's a right angle triangle. They even tell you that in the image. Okay, and so by definition, a rectangle, which they've told you it is, has to have right angles. Okay, so we know the length of this side here is square root of 5. We know the length of this side here is square root of 20. So we should be able to use trigonometry to find the answer. Now, we could use Pythagoras to find the distance in here. Why? We're not being asked that. Okay. So what we need to do is then go, well, if it's not Pythagoras, it'll be the sine cos tan rules. Now, I've written them out here, so they're handy for us. If that's my case, I could redraw the triangle. Might be no harm to do it, okay? Just sit there. So square root of 5. Now it is right angle, even though that doesn't look like it is. Square root of 20. And that's what I'm looking for. Now this gives you a chance to lay with the diagram without cluttering up your own one. So that's the angle I'm focused on. That's the opposite. Okay, it's going to use OPP for opposite. The side adjacent to it is the adjacent. And the side across the triangle, the longest side, is the hypotenuse. It's going to say H for hypotenuse. Now, if I try to go through these formulas, which ones do I have? What information do I have or not have? There's 3 unknowns in any one of these formulas. Okay, I need to know at least 2 of the 3 things. And the thing I don't know should be the angle. So that's what I end up finding. Let's see if sine works. Okay, so sine, I don't know the angle. I know the opposite. Don't know hypotenuse. In cos, don't know the angle, so I'm looking for. I know the adjacent, don't know hypotenuse. So you're left with tan in the end, which is basically a mixture of sine and cos. I don't know the angle, so I'm looking for. I know the opposite, I know the adjacent. So I know 2 of the 3 things. Tan should work. Now that's the question there. Okay, so tan of the angle ABD is equal to opposite or adjacent. So I put the numbers in. Tan of the angle ABD equals the square root of 5 over square root of 20. Okay, Now I'm trying to find inverse tan, so I want to find what number on the tan log tables corresponds to that number. Now, even though it doesn't look like a number, that is a number, okay? Just have to just like find out what it is by putting it through the calculator or working out whatever. So it is a number. In the tables, in the database, now it's stored in your calculator, which is how you're going to access it. You're basically looking for what number is in the database that corresponds to the tan angle. Now we can retrieve that. It's in the second tan database, one way of phrasing it. So if I find inverse tan of that fraction, I'll retrieve the answer. The answer that retrieved on my calculator was 26.565. The question says they want their answer to the nearest degree. Okay, 26.5. So you look at your number prior to or just after what you're rounding to. That's 5. So the next number goes up to 27. And you get your 27 degrees. Now it's the end of question 3. Okay, so thanks very much. It went on a bit longer than I would have wanted, but see you on question 4.